earlier, okay, for the lecture. And then a 10 minutes break, we're going to the lab session, okay? All right, we learned before, this is the symbol of the diode. This is the plus. This is the minus. The plus called as the anode. Minus, it was cathode. Maybe in the quiz or the exam, I'm going to blank it, okay? I'm going to blank it. You can write equations unit, the cheating sheet, only one page, one side, but no circuit, okay? No circuit, no definitions, okay? But you can write in any formula, any equation, no circuit, no formula, I'm sorry, no circuit, no definitions, and no solution, okay? So this is what we wanted to do. Why? Because I really simulated the questions a little bit modified from the lecture. So if you understand the concept, definition, and any questions from my lecture, at least you're gonna B. Okay, but if you want the A, you study more from the books. But so again, the basic semiconductor devices control flow of electrical current in a circuit. So we learned before in the previous chapter, it depends on depletion layer we can control, right? So that is the plus, the anode, minus cathode, the current like this one. The line in the devices, that was the minus, and no line is called the plus. So when you're using the diode has priorities. One part is plus, one part is the minus, okay? Now, that is the LED. We have in the backside red, yellow, green LED. Each LED has like this one long leg. It was plus, short leg is the minus. So that was plus part is anode, and cathode is the minus. The symbol is for like this one, okay? So when you connect to the battery, with the maybe LED, long part, and I'm sorry, like this one, short part like this one, plus the long leg, minus is like the short leg. So when that was for the 9 voltage battery, we learned before, okay? I'm going to quickly go over the reminder of you. The one resistor and one green LED, and voltage drop is like the 2 volt, okay? It's right there. What is the power dissipated by the LED? What is the power? So the first step, you have to know about equation formula. What is the power in the D circuit? That was VI, sometimes I square R, sometimes, how can I say? R square, V square, something like that. But now, if we know the I here, diode, that should be for VI. We know the voltage is 2 voltage, and I is very simple. That is the only one LED, the diode. We assume that usually LED for the 2 voltage. It's very important, the 2 voltage. So 9 minus 2 divided the R, 680, okay? 7 divided 680, you can calculate it. Just give me a second, let's try. 7 divided 680, so 680, that was the 10.29 million, okay? Any questions so far? Okay, it's fine. All right. So now, okay, in the previous slides, we learned before about the DC voltage supply. I think some students now they're learning about the AC circuit, but that is the AC sources. AC source means they can generate signals, sometimes the plus, sometimes the minus. It was the periodic sinusoidal waveform. Okay, now that was for like this one, split up the 2 line, the 2 paths. One is forced red LED. Second one is the green LED. But I'm going to marking is X. Why? Len, why? God bless. Thank you. You got an A. Oh, asking? Yeah. Houston. Why? Because that is the reverse. No current here. Yeah, so this is why. So it means first step here, maybe in this graph, in the circuit, only red LED, the light on, the illuminated. But after the T/2, the T is the period. That was right, this one. The first one for the red LED, that was the open circuit. Why? That was the reverse bias. Reverse bias. So the green one is the light on. So like this one, the red LED, the green LED light on, red, green. We can control. It depends on the delay time. You know what I mean? Red, green, red, green, red, green. So that was one more time the review for the diode characteristic. That is the symbol, schematic symbol. That is the appearance. The line is minus part. Be careful. The rear diode, the line is the minus part. And then only one direction of the normal diode current flow from the left to the right. And then that was the graph behavior of an ideal the diode, the current through the diode, some point is the voltage was working. It depends on the silicon 0.7, germanium 0.3, the LED is the 2 voltage. Okay. So now from these slides, we're gonna one more time to explain about the Zener diode. Zener diode. Okay, Zener diode is a really special type of the diode, was designed to work in reverse breakdown regions of its characteristic curve. Okay, what does that mean? Usually, the diode, this is normal operation of the right direction, but the reverse diode, no current. But Zener diode, like this one, for bias, for example, that silicon and V sub Z5 voltage, silicon that was the working the diode, just like this one. And then the reverse bias, just like V sub G is equal to like this one here. It was working the bidirectional. Okay, it was working bidirectional. That was for the Zener diode, the Zener voltage. Okay. Okay. Now that is we learned before the Zener operating characteristics in this graph. So maybe again for the reasons, the for bias, the V sub F, it depends on the silicon or germanium that was working 0.7 volt and 0.3 volt. Okay, and then in the leakage regions means the between 0 to the minus, the reverse part, it has only slightly small reverse current. Okay, but after that, in a Zener diode, the breakdown has very sharp need right there, followed almost vertically increase in current. Okay, so right there they have the 3 different part of the Zener current. The first one is the Zener knee current right there. That is the minimum value of Zener reverse current required to maintain voltage regulations. And then after that, the Zener test current, that's right there. That was the value of Zener current at which the nominal value of the components are measured. And then the last one is the maximum Zener current, I sub G sub M. So the maximum lower value of Zener reverse current, okay? So that is the 3 different point of the Zener currents when they reverse bias. That is very important. Okay, now the Zener diode operations under one conditions in the reverse bias. If the V sub in is greater than V sub Z, V sub out is equal to V sub out is equal to V sub Z. Okay, so what does that mean? Like this one here. This is 5 voltage, 1 ohm, silicon, and V sub Z, for example, the 3 voltage. Now, we are looking for the V sub out here. Okay, now that was the current from the plus to the minus, like this one. What is the V sub out? In here, 5 voltage is greater than V sub G, 3 voltage. It was working just like a V sub G is equal to 3 voltage. That is a V sub out. Okay, it's very important. Very important. Maybe how about this one? 5 voltage, 1 ohm, just like this one here. Silicon, V sub G, the 3 voltage. What is the working as the Zener diode? The what voltage? 0. What? 7. Oops. So now, one more time. For bias, the Zener diode working as 0.7 voltage. But reverse bias, that was working as some specific assigned voltage, V sub C. In here, the 3 voltage. That is very important. Okay. But one more time. The for bias mean the passing through the current, the Zener diode, it works as the silicon, the diode. The reverse bias that was working as the specific assigned the Zener voltage. But Zener voltage should be less than the V sub in. Okay. All right. So for example, the page 14, the page 14. 400 ohm, the V sub G is equal to 10 voltage. This is silicon, means like 0.7 volt. Okay. What is the current of the Zener diode? That was the Ohm's law. The supply voltage, the 12 voltage, is DC voltage, minus, as I said before, the 4 bias here, they're working as just diode, silicon. So 12 minus 0.7 divided what? The register, maybe only one register in this circuit, 400 ohm, just divided. I'm going to write in here, 12 minus 0.7 divided 400. That was for 28.25 million. Okay, all right. So the next one is what? Supply voltage, the 12 voltage, and then the register is 400 ohm here, and the Zener voltage looks like reverse. Reverse means you have to step one, you have to approach the step one. E should be greater than V sub Z. E is 12 voltage, V sub Z 10 voltage. Oh, okay, it should be working. It should be working. So the total current is equal to the Zener current with 12 minus 10 divided register. Okay. Now, Zener voltage regulator. The Zener diode can apply to the voltage regulator. Okay. Zener diode, a lot of maybe options to the applications, but in here we're gonna want to have a sample application, the voltage regulator. How can the Zener diode work in the voltage regulator? Okay. So now the Zener diode is sometimes called a voltage regulator diode because it maintains a constant output voltage, even though the current through interchange. So the total circuit current, the source of current is like this one. The V sub in is right there, minus V sub Z divided the R sub S. Because we want to looking for the total current, okay? Now we are looking for total current. So that was the V sub in minus V sub Z divided the R sub S, okay? So what is, that is just the formula. I mean, the next slides, we're going to learn about very the sample questions. But now you can find the source current, or sometimes called as the total current, that was to make a difference between input voltage and the Zener voltage and divided the source register, okay? So now, in here, they have 3 questions. What is the total current? What is the Zener diode current? What is the road current? And then what is the road voltage? That was in here. That was in here. The first one we learned before, the I sub T is the 20 minus 0.9 volt divided 2.2K ohm. Because the 20 voltage, supply voltage, is greater than the Zener voltage, so this is why we can work as like this one, 20 minus 9.1, the divided the 2.2K. So that was the 20 minus 9.1 divided 2.2. So that was 4.9 milliamp. Any questions? Okay. So the question 2, very important. Very important, only one reason. Okay. Very important, only one reason. So what is for I sub L? What does that mean? I sub L. It's like this one. And here, from the junctions, I'm entering the junction A, the I sub L, and from the A to the leaving, split out the 2 currents. This is the current divider rule. I hope that you can check. The remind of you for your DC circuit means I sub T entering current should be equal to the leaving current in the junctions, I sub Z plus I sub L. Okay. All right. So now, so I sub L is equal to V sub R sub L divided R sub L. R sub L was given the 10K, and V sub R sub L should be the same as the Zener voltage because they are in parallel. They are in parallel. So V sub Z is what? 9.1 voltage. Thank you, Len. So 9.1, the divided the 10. Oops, 9.1 divided 10. Okay, 0.91 million. So what is for I sub Z? The I sub Z is the I sub T minus the I sub L. Okay, so I sub T is what we have already calculated before, 4.9 milliamp, and I sub L from the B, that was 0.91 milliamp here. That was 3.2 what? 9 point minus 0.91 is almost 4 million, right? So that was 4 million. That is the answer. Okay. Any question so far? Okay. 3 point, oh, it's fine. Yeah, it's fine. So when I, will be grading in the lab quiz exam, the point with decimal is like, for example, the answer is like a 3 million. You writing the 2.1, 3.94, it's fine. But the answer 3 million, but you writing what 10 million? No, it's wrong. It's really too far away from the answer. So don't worry about that. But don't missing the unit. And also some students just like this one. Can you see that right there? What is that? The numerator 7, the denominator 4. Honestly, that is wrong in the exam, but the quiz, the lab session, I'm going to waiver. But usually you have to writing 1.3. Okay? Not, fractional value. All right, so that is what we have. Any questions? All right. Okay, but Houston is fine. Good. All right. Now that was for the last questions. This is the 2 Zener diode, right? Not only 1 Zener diode. A little bit looks like tricky, but no, it's very easy. Very easy. Okay. For example, they have the maybe AC sources. That was the peak-to-peak voltage. Means the peak voltage is what? God bless JC. Thank you. 2 voltage. Thank you. So the AC source means 1 period, 2 period. Professor, what does that mean? Red. This one is what? Reverse. Okay. One more time. Forward. Write this one. Reverse. Just write this one. So now, very easy. Don't worry about that. So we are looking for what is for the V sub out. That is the questions. What is V sub out? And then draw in the graph. I might be able to ask you in the first exam, just like this one. Okay, so first one, in the AC sources, the current flow from the plus to the minus. Okay, from the plus to the minus. So in here, I'm gonna a little bit more like this one here. So like this one. That is for what? The reverse. What is the V sub Z? The 2 volt. And then that was the second one is what? The forward. Is what? The silicon is what? 0.7. So the out voltage 2.7. It's like this one. Okay. Hey, professor, why they have the clipping? Why they have the clipping? Because this is the 2 volt. Oh, I'm sorry about that. This is the wrong. This is the P. Okay. No. Hold on. Let's say yes, the peak voltage. So that was the clipping because the forward here, that was the 2.7. Okay, 2.7 applied to the out voltage. But here, reverse bias here, that was for what? This should be the V sub Z. Is what? The 2 voltage. This is the forward one. The silicon is what? 0.7 silicon. So that is also the 2.7. But that was minus because that was from the minus to the plus. Okay. So the clipping from the 4 voltage. Okay. For my wrong, please, you have to change. Not peak to peak. This is the peak voltage. Okay. I'm sorry. Peak 4 voltage. Yeah. All right. Any questions? Okay. Yes, Aaron. Any question? It's fine. Are you sure? Okay. All right. So today we're gonna finish earlier. Okay, but 10 minutes break. And then still 2 teams. Okay, or do you want to do the work with maybe Aaron, or what do you want to do?